Hello there. So in our previous video, we had to draw this probability tree diagram, which shows the outcome of tossing a coin 3 times. We have here the sample space or all the possible outcomes we can have, and there are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Each of these is called an event. If you want to understand more, watch the video on this page titled The 8 Outcomes of Tossing a Coin Thrice. So now there are some questions that came from this tree diagram. And very quickly, we will dive into these questions. So the first question says, what is the probability of getting 2 heads? What is the probability of getting 2 heads? So we will go to our possible outcomes. And in our possible outcomes, we will look at every event that gave us 2 heads. This one gave 3 heads. This one has 2 heads, so we'll count this as 1. We will look, this one has 2 heads, head and head. We'll count it as 2. And we'll look at this one, it gave 2 heads, or it includes 2 heads. So we have 3 possible favorable outcomes, or 3 outcomes that will favor 2 heads. One, this one here, this one here, and this one here. So to find the probability of having 2 heads, we will say P, and this is how you write it, P, like this, in bracket, 2 heads, P of 2 heads. Now the formula is equal to, you say, all the favorable outcomes. How many outcomes favor 2 heads? Favorable outcomes divided by the total number of outcomes. So we have divided by total number of outcomes. And so when we counted, we had 3 possible favorable outcomes, which contain 2 heads. So we'll say here 3 divided by how many different outcomes are here in the sample space? There are 8 different outcomes in the sample space. So our answer is 3 on 8 for the probability of 2 heads. Take note, a probability can never be negative. A probability can never be greater than 1. So all probability values are between 0 and 1. A probability can be equal to 1 for events about which we are absolutely certain. For example, it is a certainty that everyone will die someday. The probability of 0 is assigned to an event which is impossible. For example, if they ask you, what is the probability of finding out that the sun is made of paper? Of course, it is impossible for the sun to be made of paper. So this probability will be 0. Every other probability falls between 0 and 1 or is equal to 1. A probability will never be greater than 1 or never be negative. So the second question that was asked was, the question said, find the probability of getting at least 1 tail. So it means that 2 or more tails can be included. We'll go back to our sample space and we'll check each of the events. And we want to pick out all the events that contain at least 1 or more tails. These events, we'll consider them as our favorable outcomes. So here we have 1 tail, so that's 1 event. Here we have a tail, that's 2 events. Here we have 2 tails, that's 3 events. We have 1 tail here, that's 4 events. We have 2 tails here, that's 5 events. We have 2 tails here, that's 6 events. And we have 3 tails here, that's 7 events. And so the probability of having at least 1 tail, so we'll say here, the P of the probability of at least 1 tail, is equal to, there are 7 possible outcomes where you would find at least 1 tail, and the total number of outcomes, or the sample space, there are 8 events there. So we have the probability of at least 1 tail is 7 on 8. Now the next question says, find the probability of getting 3 heads. 3 heads. If we go back to our sample space and we look at all the events, which of these events favors 3 heads or has 3 heads? Well, this is the only event here that has a head, and a head, 3 heads. There is no other event here that gives us 3 heads. So the only favorable outcome is 1 out of all the 8 possible outcomes. So we will go back and say the probability the probability of having 3 heads, P of 3 heads is equal to, there is only one possible favorable outcome which contains 3 heads, divided by the total number of outcomes, 1 divided by 8. And the last one says, what is the probability of having either all heads or all tails? So for the last one, it says or. Take note of this word or here. Now, when the or word is used, we call those events mutually exclusive events, meaning that these events cannot both happen at the same time. You see, in this particular sample space, we have 8 events. And in these 8 events, you can either have 3 tails or you can have 3 heads. You cannot have both at the same time. So if they're asking us the probability of having either all heads or all tails, we will say the probability of having all heads, which is 3 heads, is equal to 1 on 8. And the probability of having all tails or 3 tails is 1 on 8. So the probability of A or B, meaning the probability of having either all heads or all tails, is equals to, we will add the two probabilities, 1 over 8 plus 1 over 8. And if we add those two probabilities there, it will give us 2 over 8. 2 over 8, which simplifies to 1/4. So this is the probability of having either all heads, that is 3 heads, or all tails, or 3 tails.